Welcome to recording 1B in our series on reciprocal functions for Unit 7, Chapter 7 of Mathematics 2200. We'll be graphing reciprocals of linear functions. First, what is a reciprocal function? Well, if I give you a function y equals f of x, the reciprocal function is y equals 1 over f of x. So for example, if I have the function y equals x plus 3, the reciprocal function is simply y equals 1 over x plus 3. First of all, though, we need to look at some terminology. An asymptote. That is a line whose distance from a given curve approaches 0. So if you take a look at this curve, the brown one, there's this dotted vertical line. It's not really part of the graph. However, if you look at the graph, it is getting closer and closer to this line x equals negative 3. So we would call that a vertical asymptote at x equals negative 3. This graph also gets closer to the asymptote on its left-hand side, closer and closer. If we look at the end, what we call the end behavior of the graph, as x gets large, the y values are approaching 0. As x gets large, negative, the y values are also approaching 0 there as well. So if we think about those in absolute value terms, if the absolute value of x is very large, the y values will get close to 0. So we have a horizontal asymptote at y equals 0. If I put it into place, is actually coinciding with the x-axis. Now an invariant point. Remember, 1 and negative 1 are their own reciprocals. So they're invariant. We learned about that in recording 1a. So we're interested in where the y values are either 1 or negative 1. That seems to occur right here at negative 2 and positive 1. So that's an invariant point. And we have a point here at negative 4, negative 1. That's also an invariant point. The y values on y equals x plus 3 out here, they're very large positive. For a large positive that's more than 1, we learned in recording 1a, the reciprocals will be small positive, close to the x-axis, less than 1. And back here where the y values are large negative, the reciprocal of large negative is small negative, close to the x-axis. Now in this region between the vertical asymptote and the invariant point, we have small positive y values on the graph of y equals x plus 3, and the reciprocal of a number between 0 and 1 is bigger than 1. So we get a graph that takes off. And in this region right here, where I have small negative values between 0 and negative 1, for my y values that is, the reciprocals will become large negative, so it forces the graph to take off this direction. All this suggests a procedure for graphing the reciprocal of y equals x plus 3, or any linear function for that matter. First of all, we'll sketch the graph of y equals x plus 3 using its x-intercept and y-intercept. So we calculate the x-intercept to be negative 3, 0, the y-intercept by putting in x equals 0 to get 0, 3. Sketch the graph. That's kind of a guide for doing the other one. Next, we find the invariant points where y is 1 and y is negative 1. So when y is 1, we make x plus 3 equal to 1. Therefore, we get x equals negative 2. That means we have an invariant point at negative 2 for the x and 1 for the y. Now, when y is negative 1, we set x plus 3 equal to negative 1. That gives us x equals negative 4. So we have a point at negative 4 and negative 1. Now our reciprocal function is y equals 1 over x plus 3. It has a non-permissible value at x equals negative 3. That's where your vertical asymptote is located. Invariant points are also on our reciprocal graph, and the y-intercept that was on y equals x plus 3 becomes 0 and 1/3 is the reciprocal of 3. Now we want several more points for accuracy. So take a point, for example, negative 2.5 would be a good point just between the asymptote and the invariant point, and another point, say, in here, between this invariant point and the asymptote, say at -3.5. -3.5 and -2.5 are between the invariant points and the vertical asymptote. If I put them into y equals x plus 3, I wind up with -0.5 and +0.5 in this case for those two y values. So for the reciprocal function, I take the reciprocal of -0.5 and get -2 and +2 for the reciprocal of 1/2. So I've recorded those points back here. -3.5 and -2 would be down about here. And meanwhile, -2.5 and 2 would be right about here. Now I want a couple of points as well to help me with the end behavior as x gets large and as x gets large negative. So on my scale I can go out to 10 here and -10 here. So in other words, I need to figure out these points. What are the y values that go in there? So 10 and -10, there are large positive and negative x values to help determine our end behavior. They're the largest ones that our scale will really allow. So putting those values into y equals x plus 3, I get 13 and -7. Take the reciprocals to get points on the reciprocal graph. So 10 and 1/13 would be really close to the x-axis. It's a small positive. -10, -1/7. -1/7 is pretty close to the x-axis back here. And now I can do a rough sketch of my reciprocal graph. So we can connect the 3 points on the right-hand side of this invariant point. So from here out to here, it gives us a rough guide. And then we've got a point right here going up from the invariant point, and the points will increase. We repeat the process over here, connecting invariant point to this point back here. And now we'll sketch down here. Below the invariant point, connect the point that we have there. The graph takes off because we're getting large negative values for the reciprocals of these small negative y values here. In conclusion, the steps that I've outlined in that example are repeated here for you. Please take a moment to review them.